Hi, I want to give some explanation to some examples of finding the area of regular polygons when only one length is given to you. When only one length is given, whether it be the radius or the apothem or the side, you have to use trig ratios to determine the apothem and the perimeter, unless you have a special right triangle like 30, 60, 90 or 45, 45, 90. So let's look at these examples. Again, the area of a regular polygon is 1/2 times the apothem times the perimeter. Remember, the apothem goes from the center of a regular polygon to its side perpendicularly. So this red segment would be the apothem of this regular octagon. And remember that from the center to the radius, or from the center to the vertex of a regular polygon, this is a radius. Okay? Just a second. Okay, I had to answer the door there. So the red segment here is an apothem. We've got two radii going from the center to the vertex, or the vertices of the octagon. So these are radii. If you were to construct a circle, from the center of the octagon through the vertices, it would share the same radius as the octagon. Since they are radius, we've got an isosceles triangle here. Now remember the isosceles triangle, when you construct a segment from the side to the vertex, it's going to be perpendicular. So this is an altitude, it's an angle bisector, it's a perpendicular bisector. These are all things that the apothem is. All right, so again we have one side length, and we're going to have to use either special right triangle theorems or trig ratios to get the apothem, and then also to get a side length so that we can get the perimeter in order to find the area of our octagon. So let's start with perimeter. Okay, we're going to start with the perimeter. I'm going to call that X. Before we can find X, we need some angle measurements. We need to know what type of right triangle we have. Notice the apothem constructs two right triangles, or creates two right triangles. So I start with the central angle. Let me find the central angle here. Okay, the central angle is going to be 360 divided by, whoops, didn't want to do that. Let's see what happens when I do this. Okay, so the central angle is going to be 360 divided by 8, which is 45 degrees. All right, and then when the apothem is going to cut that 45-degree angle in half, so this angle measurement here is 22.5 degrees. And we've got a 90-degree angle here, and let me see if I can make this 2 look a little better here. Got a 90-degree angle, this 22.5-degree angle, and we could probably get away with, we probably don't need this angle here, but that would be 67.5, this angle would be here. All right, so again, we're looking for X. If I can get X, this is half. Remember, this apothem is a perpendicular bisector, so this is half the side. X is half the length of the side of this octagon. So if I can get X, I can double that. That gives me a side length, and then multiply it times 8. That gives me the perimeter. So let's go ahead and find that. So we need to determine what trig ratio we're going to use. Sine, opposite, which is opposite over hypotenuse; cosine, which is adjacent over hypotenuse; or tangent, which is opposite over adjacent. We can determine our ratio based on what's given and what we need. We need a leg, and we're given the hypotenuse. All right, so that means we're going to be using sine or cosine. I'm going to use my 22.5 degree angle as reference, so I'm looking at opposite over hypotenuse. That's sine. So that means the sine of 22.5 has to equal opposite over hypotenuse, x over 20. All right, so I'm going to solve for x, the leg length. It means I'm going to have to multiply both sides by 20 to get x by itself. So that means x is equal to 20 times the sine of 22.5. Which is approximately 7.65366 and so forth. I'm going to round that to 7.654, approximately 7.654. Now I can use this as a leg length, and then S, my representing my side length. If I double that, I've got 2 times 7.654, which is equal to 15 point, I'm going to call that 15.31. Okay, so that's the side length, and then I've got 8 sides. So my perimeter is going to equal 8 times 15.31, which is equal to 122.48. And that's units. Okay, so that's my perimeter. Now, not to confuse you or anything, but I'm also going to represent my perimeter with a sine ratio function, just so I can get more of an exact value of the area. So in my figuring, I could use this. This is good enough for my perimeter, but I'm also going to represent perimeter as, let's see, you got 20 sine 22.5. That's half a side. So if I double that, I've got 20 times 2, which is 40 sine 22.5. So a side length is 40 sine 22.5, and I have 8 of them. So, oops. I'm also going to represent the perimeter as, so I had 40 sine 22.5, and there's 8 of those, so 8 times 40 is 320. So I got 320 sine 22.5. Okay, so this is what I'm going to use when I calculate the area. So I've got perimeter now. I need to solve for the apothem. I've got 2 side lengths now. If I use this as my side length, I've got a side length, so I could use the Pythagorean theorem. I could use 7.654 and 20 to solve for the apothem. But to be closer to the exact value, I'm going to use a trig ratio. So I'm looking for, I'm going to call this A, the apothem, and I've got the hypotenuse. So from 22.5, that's adjacent over hypotenuse. That's cosine. So the cosine of 22.5 has to equal A over 20. So I'm going to try to get A by itself by multiplying both sides by 20. And I end up with 20 cosine 22.5 is equal to A. All right, so A is approximately 18.478. All right, 20 cosine 22.5, 18.478. So that's my apothem, but again, I'm going to, you could use this. I'm going to use this. for my area. So I'm ready now to get the area of the regular octagon. So area is 1/2 times the apothem, which is 20 cosine 22.5 times the perimeter, 320 sine 22.5. Okay, so we could just do 0.5. I'm going to use parentheses, make sure I don't get any of my operations wrong. 20 cosine 22.5, close parentheses, times open parentheses, 320 sine 22.5. And I get 1,131. I'm going to round to the nearest hundredths, 0.37. All right, so there is my answer for the area of this regular octagon.